Hey everyone, this video is about Garage Mote, a Moteino shield that can detect the position and open or close a garage door. The project came about for several reasons, but mainly because as I'm adding more Moteino-based home automation devices around my property, one of the nice things that I always wanted to be able to do is control the garage door remotely. It's become so routine to close the garage door when I leave from home that sometimes when I'm already 5 or 10 minutes away, I wonder if I actually closed it. And so I want to be able to check the door status and close it if it was left open by mistake without having to go back home. Or perhaps it's just useful to be able to let someone in without giving them the garage code all the time. The hardware is very simple. The shield has a small relay, diode, two resistors, and this 8-pin header, which has connections for two Hall effect sensors and the garage door opener. I used a female socket header to connect a 8-wire cable to the two sensors. One sensor is for the open position and one is for the closed position. That way you can tell whether the door is open, closed, or stuck somewhere in between. The other two wires are just a contact closure driven by the small relay on the shield to trigger a door action, and are connected directly to the garage opener. This is equivalent to operating the garage from the wall-mounted button. The brains is of course a wireless Moteino sender node which reports door status changes and can receive commands to trigger a door action. The receiving end is another Moteino that acts as the gateway between the home automation wireless network and the Raspberry Pi, which in turn is responsible for bridging the home automation to the web, so it could be accessed remotely from anywhere on the internet. One challenge was to secure the Raspberry Pi against eavesdropping and unauthorized access. This is achieved using SSL encryption and authentication. As a web server, I'm using NGINX, and the backend home automation is driven by Node.js and Socket.io, which is proxied through the web server as seen in this diagram. This gives two big advantages. First, the application is event-driven and doesn't require me to sit there and hit a refresh button or refresh the browser every time I want to check if something happened. The WebSocket means the application is real-time and will broadcast events to all connected clients. Second, because the WebSocket is proxied, it is running on the same port as the web server, so it doesn't expose the internal port that it's actually running on. The implementation details of this Raspberry Pi web server WebSocket stack are posted on my blog at lowpowerlab.com, so be sure to check that out. Now I'm just going to show you how the garage opener interface works. This is a simple web interface that has a status button which shows the current garage door position and can be used to query the status at any time. Then the door action button, which will say either open it or close it, depending on the current status. The clear button will just clear this log, which displays the Moteino output, which is being broadcasted from the WebSocket. You can actually see down here that the garage door was recently opened and then closed, letting me know that someone just pulled into the garage. Garage mode can be mounted on the side of the opener using Velcro tape, and an old phone charger can be used to power the Moteino. The two Hall sensors are attached in such a way to detect the small magnets that are mounted on the belt or chain of the opener. In my case, the magnets are Velcro taped to the belt and move along with it. Using Velcro allows for easy adjustments when testing the magnet's positions. When the door is closed, the magnet on the closed side is detected. As the belt pulls the door open, the magnet moves away and the other magnet comes on the open side. This way I can always tell whether the door is open or closed or stuck somewhere in between. We're here in the garage and I already have a garage mode installed in my opener. You can see the status LED on the Moteino is now solid on, which indicates that the door is closed. When the door will move, the LED will pulse, and when the door is open, the LED will be off. In case the door gets stuck, or in other words, neither magnet is in its normal resting position, the LED will blink on and off and the status will be updated to unknown. Now, unfortunately, my smartphone has really bad Wi-Fi and cellular signal in here, so I'll just pull up the web app on my laptop. The first thing I get is this SSL warning. The browser by default will warn me that the SSL certificate is not signed by a certified authority. But that's okay since I self-signed the certificate and I trust it. So I'll go ahead and just click proceed. All the communication from this point on will be encrypted. Then I get this login prompt, which is just basic authentication on the NGINX web server. And once I enter the credentials, I will see the web app. When the socket client connects for the first time, it'll ask the socket server for the current status, and then any later status changes will be updated automatically from the socket server. Now what I want to do next is use the regular garage opener to open the garage, and I'll just walk up there, push the button, and see what happens. The garage is now opening, and the status LED is pulsing to indicate that the door is moving. On the application, the status has been updated to opening. Once the door is completely open, the status will then be updated to open. I can now go ahead and click the close it button in the application, and the same process should happen in reverse. So there it is. The application is event-driven, meaning that you don't have to refresh the browser to get the latest status. And this was one of the important things that I wanted for my home automation gateway. So I hope you enjoyed this video. All the source code and Raspberry Pi implementation details will be posted on my blog at lowpowerlab.com. And I hope to soon be able to offer Garage Mode as a kit at the Low Power Lab web shop. See you next time.